The next talk is a collaboration between UIUC and UNC. It's titled Large-Scale Google Street View Images for Urban Change Detection. And the speaker, I believe, is Fangzheng Lyu. Is that right?
So, hello, my name is Fangzheng Lyu, and I am a PhD candidate from the University of Illinois, Urbana-Champaign. It's a great pleasure for me today to representing the team to share our research projects on large-scale Google Street View images for urban change detection. So firstly, I would like to talk about two types of urban changes, urban sprawl and urban retrofitting. So urban sprawl has a very long history featuring the spread of urban development, mostly spatially. So from a small town, and when we are building more and more buildings surrounding it, it's become a big city. So that process is usually categorized as urban sprawl. And as in the recent past few decades, as the sustainability become a major goal for urban development, urban retrofitting is becoming more and more popular, characterized by urban changes occurring at a micro scale and or under the roof for support sustainability. So for example, if we want to install ecosystem, if we are making micro change environment in terms of vegetations, and if we are like adding another small set of building or change the building functionality, that was usually categorized into urban retrofitting. So, urban sprawl has traditionally been used detected by remote sensing imagery. So over the past few decades, the detection of the urban changes, especially referring to the urban sprawl, has primarily relied on remote sensing imagery. And such as building changes, vegetation changes, water body changes, and land use land cover changes. So there are a lot of literature out there talking about how to use remote sensing imagery, specifically referring to satellite remote sensing imagery for the change detection. And those algorithms has been proven to be very efficient. However, on the other hand, when we are looking at urban retrofitting, the story is a little bit different because urban retrofitting often do not entail substantial alternation to the physical infrastructure of the building. So that is to see the building itself doesn't change that much. So urban retrofitting sometimes involves the refurnishing of the building. It involves adding another small components to the building. So this changes, or even like if we are changing the functionality, so the building stays the same, but who is using it and what this building is used for. So this thing has changed. So as a result, remote sensing will have a difficulty to get to know if there is urban retrofitting happening for that area, especially due to the limited spatial resolution it can provide. So we need a new things. We need a new data set for urban retrofitting detection. So we put our eyes on the street view imagery because it provides you with a very detailed images of the area of the building, and we have the historical images to compare with, so we get to know whether there is an urban retrofitting happening there. So the goal for this project is to test if the street view images can be used to detect urban changes and especially urban retrofitting. So the first thing we are doing here is to collect a large-scale street view images for these purposes. The study area we're choosing is in Mecklenburg County and North Carolina, which is the home to the city of Charlotte. There are over 1.1 million people living there, and there has been a very rapid urbanization process happening over there. So in the past 20 years, from 2000 to 2020, there has been more than 60% of the population increase in that county area. So just a very straightforward images about visualization about the changes of the land use land cover here. So as you can see, the first image on the left represent the urban area on 2001. So the lighter color is like a lower density city, but the darker color is a higher density city. So as you can see, there are some urban sprawl happening from 2001 to 2019, especially in the suburban area, if you can look at the northern part of the city. However, if you focus on the downtown area, the pattern is basically the same. It doesn't change that much. So we go back to check if there is a lot of changes happening in the downtown, and we still find a lot of urban retrofitting projects, especially in the downtown area, trying to promote the sustainability goals for the city of Charlotte. So here, we are doing the data collection, and we want to try to collect a large-scale street view images here to serve for the purpose to decide whether we can use the street view images here for the urban retrofitting detection. So there are two major algorithms here. So the first one is used basically to capture the street view with the input of longitude, latitude as a location, heading as basically where the camera is heading to, and also the pitch value, which is the distance between the camera and the ground. So given this, we will be able to use the first algorithm here to capture like a time series collection of images starting from the very first day there is a street view images all the way to the most recent one. And the second algorithm here is basically used for batch data collection. So there is in total 555 census block group in the Mecklenburg counties, and we're picking 10 random location per census block group. And in every location, we are choosing 4 headings per location. So here, this is like the batch, the big data collection algorithm, and that's running for like a weeks, and it give us this data set involving over 600 gigabytes of data, and it contains over 95,000 images. There is about 30,000 set of images. That means like that one set includes a time series collection of all the images collected on that specific location and heading combination. So on average, there are 7.25 images per location and heading. And as you can see in the figure here, all the black dot here represent the location where we have the data available in the data set. So the next thing we would like to do is to use this data set and to see if this geospatial data set can serve for the purpose for urban change detection, especially focusing on the urban retrofitting problem. So we borrow the concept from the domain of urban planning and urban retrofitting to, there are 3 major categories they have under the urban retrofitting and urban changes category, which are rebuilding, basically just intensification of urban space utilization. So for example, if there's a new building getting constructed, that fall to the category of rebuilding. And also we have regreening, mostly dealing with the green space increase. We have a park, we have a new park, we have a new greenway, have a new green belt, that'll be categorized into regreening. And recapital, that is more like specific to the retrofitting, because that will involve the functionality change, the urban building functionality change aimed at enhancing either the land value or to promoting the sustainability. So we dig into our data set and to look for if there is something in the data set that can represent these 3 types of urban changes. So the first thing is very straightforward, the urban rebuilding. We found this example in our data set located at downtown Charlotte at the intersection of West Chase Street and North Church Street. So as you can see, all the way, the first data set getting collected is on February 2008, and the last one was collected on March 2021. There is about 1 images collected every year, but it depends. If it's like downtown area, there will be more images, but if you go to the suburban area, there will be less. But anyway, so here, all the way from February 2008 all the way to March 2018, we haven't detected like a major urban changes here. But starting from the March 2008, if you look at the bottom row, to April 2019, there is like a big building getting constructed. So this is just brand new hotels getting constructed in the downtown area. Okay, the second example we would like to look at is urban regreening. So this example, we found it at 936 South Boulevard at Charlotte. So there are two types of urban regreening happening. So first is the roadside regreening, and the second is the green belt getting established in the middle of the two-way traffic. So if you take a look at the image on the top, the October 2007 one, so it's basically just road. And from 2007 to 2021, there are roadside regreening happening. So basically vegetation, there's something like trees, grass getting planted on the roadside. There's also green belt established between the two-way traffic. So that is to see, originally this was just road. And we have more this kind of project getting established. And for example, the park one, it might be easily detected by remote sensing, but if we look at the regreening things between two roads, that can be very challenging for the remote sensing to grasp. The last example I would like to show is the urban recapital. So this example, we found it on the North Davidson area. The Charlotte people call it NODA area. So this is a very popular area right now for mostly artists and musicians. So if we look at these images, there is functionality change. So if you might not be able to look at very clearly, but from 2008 February all the way to March 2020, this building was served for the purpose for, it's called a Lyu Academy, which is for mostly educational purposes. But between March 2020 all the way to August 2021, the functionality changes. So if you can take a look at the bottom rows, the image in the middle, the left-hand side becomes our marketplace called Exchange, and the right-hand side stay the same. It's still the original academy. So here, even the building itself doesn't change, but the functionality change. So who is using it and the land is changed, and the purpose for the building usage has changed. Okay, so basically in this project, we would like to investigate whether the street view images can be used to identify urban change, especially the urban retrofitting changes. So in order to achieve this goal, firstly, we are collecting a large-scale data set from the Google Street View images that can be utilized to detect urban changes. Especially, we focus on the micro-scale urban retrofitting problem. There is ongoing work from us. We are trying to build a model. Maybe machine learning model is something in our minds right now to automate the process of urban change detection. So there are three questions we like to answer. First is whether there is urban change happening throughout the time period here. And the second, when that change is happening. And the third question is what type of changes is happening over there. Yeah, that's pretty much it. Thank you.